Hey, this is a great question, and the questions come in is, do ZP have experience of our sensors being used in low Earth orbit? Really appreciate the question. In fact, I'll just, yeah, here we are. I've got a sensor here. The good thing about these kind of sensors is they're robust. So there's definitely a sort of a much better propensity to put these into a low Earth orbit than other types of sensors. And this one's still on its carrier, but anyway, that's what a sensor often looks like. Um, they ask, they have the following questions: have we tried them out in conditions or expectation in low Earth orbit? The quick answer is no. I mean, I don't really have any expectations on it. It sounds a bit ridiculous, but um, I must admit, you know, I mean, biosensors or these kind of sensors, I think they're in particular interested in pH. God, I could really start waxing lyrical actually, because there is a temperature component in a pH sensor, but um, I don't think it's gonna. I think it's still gonna function. So that's a quick opinion from me. As long as you have liquid phase, you can still measure the pH of it. You must appreciate we have very little experience in low Earth orbit. I don't, so the quick answer is, I can only speculate, and I think the only thing you can do is buy and try. Um, we can have any configuration, but to be honest with you, you don't want to get into the world of bespoke biosensor development, because bespokeness means it should be expensive, but actually people want it at low cost, and because they're not willing to pay the high prices for customization, they go around, they get low cost, but then they actually have low quality. So be very careful about actually um, doing custom configurations. We are capable of it. What's the power consumption? I think they're in particular interested in pH sensor. What's the power consumption? pH sensors actually have a low power consumption. You're just reading the potential of that sensor using a high impedance circuit. You're just reading the potential, i.e. voltage of it in a high impedance circuit, so it should be low power. With us, the highest use of power is actually transmission of data, but in your particular case, you'll be taking care of the transmission of data essentially away from the sensor, so I don't think really care. I can't really guide you on the power consumption part. I will link you to some electronics that we have. You may be able to find the information there. And then the general pricing, I think the pricing, to be fair, is actually, I'll put some links underneath this video, around this video, both to the sensors and both to the electronics. I think it's about €385 for about 10 of them, but I'm not sure. Sometimes people ask us for different pack sizes, but we just say no. No, the pack sizes we have are on the website. The pricing we have is on the website. And yes, I'll probably put a link to all of this as well underneath this video as well. So in summary, you can absolutely appreciate that we don't have much experience with putting our sensors into low Earth orbit. Should they function? Sure, electrochemical sensors do. I've seen it in academic tomes that they do go into low Earth orbit. They're intrinsically quite robust. Power consumption intrinsically is quite low with biosensors. Can I advise you on it? No. Can I link you to some electronics where you may be able to find the information? Yes. I've probably put all of this into one single page as well, because I thought it was kind of intriguing. But I think in the end, I can't de-risk you by just giving you black and white yes and no answers. I think you in fact have to buy and try. And I will specifically link to a particular pH sensor, I think, which will be good for you. If you do have any questions about ZP biosensors in low Earth orbits, don't hesitate to reach out to us. Okay, thanks very much.